I'm William Lewis Gaddis, and this is the news on TV Theater. Many of our scientists and engineers have a talent for keeping numerous projects in the air, so to speak. Ron Graham is one of them. Ron Graham is a master mathematician and head of the discrete mathematics department at Murray Hill, and he is an expert juggler. On the surface, one would think juggling is an unusual hobby for a mathematician, but...
It's interesting, in fact, that many mathematicians and computer scientists have an interest in juggling. I think it's the search for patterns and structure that is responsible for this. Juggling is basically an algorithmic activity, that is one in which you need a definite plan, procedure, algorithm for accomplishing the various feats. And this is very typical of algorithms in computer science and discrete mathematics. For example, when you're throwing a ball from hand to hand, the path is roughly like this, and when it goes back the other hand, it looks like this. And the question is, where do you fit the balls into the pattern? So for example, with 3 balls, they're about equally spaced, so they might be about here, here, and here. Whereas if you try to do the same thing for 4 balls, so you'd have a path like this, of course the balls go this way, this way. With 4 balls, if you try to have equal spacing, you'll get collisions right in the middle. Whereas for 5 balls, then again it would fit. So understanding which patterns are possible and in which ways that are possible with the fact that we have 2 hands and however many balls we're going to be using is an example of the interconnection between juggling and discrete mathematics.
Graham is the editor of over 20 mathematical journals. Recently he became World Book Encyclopedia Scientist of the Year for 1980, and the Society for Industrial and Applied Mathematics awarded him the Polya Prize. He has also served as president of the International Jugglers Association.
I started looking at mathematics more seriously when I began college, and that was the same time, in fact, that I got into juggling. And from that time until now, I've spent a fair amount of time in both activities.
The difference between continuous and discrete mathematics is significant, as Ron Graham explains.
Basically, you can divide mathematics into 2 parts, the continuous and the discrete. Now, the continuous tends to deal with smoothly varying quantities. For example, it's the same distinction you would use between analog versus digital. In a continuous or analog signal, you might have the amplitude varying in a smooth manner like this, whereas in a discrete or digital situation, the curve might vary in a much more abrupt way. The kinds of mathematics that deal with continuous are things like calculus, differential equations, whereas for digital or discrete processes, there are discrete algorithms in computer science and algebra, combinatorics, that kind of mathematics.
Recently, Graham and his staff assisted the Traffic Network Planning Department in designing a more efficient long-distance network, and discrete mathematics was a very important part of that task.
By looking at their problems and building a mathematical model to capture the essential parts of the problems, we were able to simplify much of what they were trying to do, and as a result, I think that there will be considerable savings in the long run for the Bell system.
Graham's latest challenge, you might say, is rather far out.
Boomerangs are basically kind of a long-distance juggling, and of course there are many different kinds, and the challenging thing about boomerang throwing, as about juggling, is not just throwing, but of course catching. And the problem comes normally when there's a little wind. A little wind makes a tremendous difference in trying to make a boomerang come right back to the spot that you threw it from.
Mathematicians and computer scientists are forever looking for ways to develop new and better algorithms which might be just as difficult as trying to catch two boomerangs at the same time. Computers and computer software are essential tools for much of our work. A talking terminal may soon